All right, so we're going to go ahead and plow through 7-9, make a video for that, and then go over this more when we see each other in class next time. So as a little bit of a review of what we did for 7-8, go ahead and remember how we simplify this. Remember, we need to look for ways of simplifying. And then here are where we have to just go back and memorize those rules. So pause the video, go back to your notes, and remind yourself of how to do these. Ready, mark it, set, go. All right, so the first thing I'm going to do is rewrite the function. I'm going to take this value and distribute it, and then that gives me something that I know how to integrate. So I remember my 12 tags along, my x goes to the 1 more power, and I'm going to divide by that new exponent. 4 tags along, x to the 1 more power, divide by the new exponent. 4 tags along, x to the 1 more power, divide by my new exponent. So when I go ahead and let me just make sure this is going to be, yep, 4x squared. And then I'm going to go ahead and divide by my new exponent. Don't forget about your plus c. And then remember to go ahead back and simplify or rewrite if you want to pull your fractions out, taking a look at some values that cancel out. There's my fraction. And then, of course, you can always mentally go back and see if you get that original function. So if I were to take the derivative, my exponent comes out, and that would give me 12x to the 4th. My exponent comes out, and that would give me 4x cubed. This exponent comes down, and that would give me 4x squared. And then, of course, I can factor out a 4x squared from each of these and wind up with my original. So when we look at this one, we know we've got some rules to memorize. So if I had 8x as my derivative, that means that my natural log got canceled out. So I'm going to go ahead and include that in my denominator. And then the derivative of 8x is 8x, ln 8, so we're good. All right, don't forget e to the x, Euler's number, its derivative and its integral are the same, and then of course your plus c. All right, so at the end of last time's homework, we kind of hinted about these trigonometric antiderivatives, and what I would like you to do is I'd like you to revisit that conversation, go back in your notes from the beginning of the year, and I want you to find the original function in your notes on derivatives of trig functions that have each of these as the derivatives. So find the original functions with these as original functions. Go ahead. Right, so when you went back through your notes, when you take the derivative of sine, you get cosine. When you take the derivative of your secant function, you get secant x tangent x. When you take the derivative of your cosine, you get the opposite of sine, but keep in mind this is positive here, so that negative has to be preserved. So the opposite of the derivative of the cosine is going to be a positive sign. Think about that for a little bit. The derivative of cotangent gives you the opposite of secant squared, so same story with that negative. The derivative of the tangent gives you secant squared, and the derivative of your cosecant gives you the opposite of cosecant cotangent, and then that negative needs to be preserved. Don't forget about your plus c's for every single one of these. So when we dive into doing these examples, it's the same theory. So what we're going to do is look for something that we do know how to integrate. Secant squared when I have secant squared x, that's from a tangent original function. So it's just going to be 3 tangent of x plus c. So we've kind of been putting a yellow star next to all the things we need to memorize, and this goes back to these trig functions. Now, between you and me, if you're watching this video, you can hold me accountable. I'll let you peek at these while we're working on them. No need to memorize. You just need to be able to recognize. There's a difference between recognize and memorize. So I'll know if you watch the video if you remind me. Let's see who does. All right. So here's something interesting, and this is where we're going to address this plus C conversation. And this is where I kind of hinted last time that we were getting to the point of taking a look at this. Okay, find the function, and I want the whole function that satisfies these given conditions. The derivative is going to be equal to 1 minus sine of x. So what I want is I want to find the integral of 1 minus the sine of x. Remember your dx. Think about what that represented as far as your height versus your width of your rectangles and the sum of the area underneath. Okay, so this is my rate of my original function, and I'm going to work backwards and find out what that original function is. We're not going to worry about this quite yet. All right, so when I have 1 minus the sine of x dx, I want to try to think about that and maybe put that into a thing that I can recognize. So when I go to find the integral of each of these values, I know I'm going to x to the 1 more power. Remember, think of this as x to the 0. X to the 1 more power, and then of course dividing by the new exponent, and minus the integral of sine of x is going to be the opposite of the cosine of x, and then don't forget our plus c. So this is kind of interesting, and I want you to watch how we simplify this. We'll go ahead and we'll call this x plus the cosine of x plus c. And what I want you to think about is this was my original function. Now we're going to come back to this conversation here because f of x is that original function. So now what I'm finding is f of pi, and I know that that's going to be equal to this pi value that's going to go in for x plus the cosine of pi plus c. Now let's talk about what we're doing and why we're doing that. We are plugging in what we know. Pi as an input, and that went in for x in both these places. Because now what I'm going to do is try to figure out what this c is. Remember that lesson last time when we have 3 very different functions all give us the same derivative? Well, guess what? We're going to use an xy ordered pair that we know is true. I know when pi goes into the function, then pi minus 2 comes out. So I know this is an x and a y of my original function. So what I'm going to do is use this input-output, and that input-output value is going to go ahead and allow me to solve for my unknown. So here's how we do this. I know that f of pi is equal to pi minus 2. So I'm going to go ahead and put that in there. Pi minus 2 is equal to, pi is fine, where it is. But what is the cosine of pi? So we'll think about our unit circle. And we know pi is over here. Cosine is our x value. So that's going to be -1. Now what I have is this ability to solve for c. So my pi's will cancel out, add 1 to each side. That means my c has a value of -1. So when I go back to write my original function of x is equal to my x plus my cosine of x. And instead of my c, which I didn't know, now I know my c has a value of -1. So that is my function. Pretty cool, right? All right, so I want you to take the time to go again back to your notes and remember these reciprocal, and we'll go ahead and put their trig identities, T-R-I-G, there we go. Reciprocal trig identities. Of course, sine is equal to 1 over the cosecant. Cosecant is equal to 1 over sine. Cosine is equal to 1 over secant. Secant is 1 over cosine. And the relationship between tangent and cotangent. And don't forget, tangent is also equal to my sine over my cosine. And this is my cosine over my sine of theta. All right. So again, the reason why we have these, oh, and here are these quotient identities right there. The reason why we have these here is because when you see the trig here, we don't necessarily know how to do this, but we can figure out a way to rewrite it. I can call that instead the integral of x minus, and instead of calling it 8 over sine squared, I know I can call that 8 times the cosecant squared of x. And of course, that's all dx. So now when it's time for me to find the integral, this is something that I have a value for. This is not. All right, so I'm going to go ahead and write my x to the 1 more power, divide by my new value. And then I know that my 8 stays and hangs out. And when I go to find cosecant squared, turn your notes over and go back and see that that is the same as negative cotangent x squared. So I can go ahead and say that's 8 times the opposite of cotangent x, and then of course my plus c. So I can simplify this to 1/2 x squared plus 8 times the cotangent of x plus c. So in each of these, I'm going to look to rewrite what I don't recognize into something I do recognize. It's on that front sheet. All right, cosine squared x, secant squared x. So go ahead, flip over to your sheet. Do you see cosine squared x, secant square, or secant x? So it's not there exactly. So what are we going to do for this one? Let's just talk about the secant. So if I need to find the integral, let's hold on to cosine squared x and let's just rewrite the secant. Isn't the secant 1 over the cosine of x? Do you see something here I could simplify? So because it's cosine squared times 1 over the cosine of x, do you see how these two cancel out? So I'm still finding the integral, but now it's just of the cosine of x dx. So this is something I have a value for. So I can go ahead and say that that's going to be the same as the sine of x, and don't forget your plus c. All right, we've got one more. I can take the integral of that. I can take the integral of that. So I know I've got 1 plus x cubed plus 1 over cosecant. If I go back to my front page, actually we can just find this one here. 1 over your cosecant is the same as the sine of x. And then of course, when I go to integrate that, x to the 1 more power, divide by that new exponent, x to the 1 more power, divide by that new exponent. And then if I go look at the integral of the sine of x, that's the one where I get the cosine of x. And then of course, don't forget your plus c. So keep these notes handy. Maybe put extra star or circle or a post-it note so you can find them, because remembering these trig identities will help you convert your rate into something that you know how to integrate. All right, one last piece of paper for you to pick up from the sub, and that is more antiderivatives. Check this one out. We'll go over them next class. Hang in there.